We're going to go ahead and work on page 2 of our review. So the very first question on page 2, problem number 7, wants to know the domain of this function, domain and range. So if I notice, my largest x value is 6. So for my domain, my largest x value is 6. This is a closed circle, so I know that it is less than equal to, and x is going to be less than equal to. But what I also know is that this just goes out forever. So I have no idea where it's going to end. So I'm going to leave it open because all I'm saying is x is going to be less than equal to 6. If there is a value less than equal to 6, then it's going to fall into the domain. I'm going to use this same logic to help with my range. But instead, this is actually going up. So therefore, this is talking about my lowest value on my graph, because it can't get below here, which happens to be -2. So I'm going to say -2 is less than equal to y. And any value that is larger than -2 would work with my range. If it was 5, it would be right here. If it was 1, it'd be right here. And if it was 10, it'd be somewhere way out here. And that's it. That's all I can write for my domain and range. On question number 8, it reads, the table shows some ordered pairs that belong to a linear function. What is the domain and range of this function? We are so tempted to just write out the values in this side for our domain, in this side for our range. And I don't blame you. However, you need to read the problem carefully, because the problem reads, the table shows some ordered pairs that belong to a linear function. So these are some of them, not all of them. Well, if this is a linear function is just a line. That's it. It could go that way. It could go that way. It could be horizontal. It doesn't matter. It's just a line. So if it's just a line, then I know my domain is all real numbers. It's not saying even values, it's not saying odd values, it's not saying whole numbers, it's saying all. My range, I don't want to jump quickly into saying all real numbers, because yes, if it matches my purple graph, yes. If it matches my blue graph, yes. But if it was my green graph, then my range would be that one singular value that repeats. So I need to look at my table and double check and make sure nothing's repeating. It doesn't look like it's repeating at all. So again, in this case, my range is going to be all real numbers. If it was repeating, then I would go ahead and just write down that number that's repeating. Question number 9 reads, what is the domain and range of the following function? 4, 9, -5, 16, 6, 25, 7, and -36. So what's different about this function is it just labels it as a function. It doesn't call it a quadratic, doesn't call it a linear function. It just labels it as a function. It also does not have the word sum. The word sum is not in there. So because of that, I know that these are all of the points. So if they're all of the points, I just have to write out the domain as the x values, which is 4, -5, 6, 7. Now, they could be written in least to greatest or greatest to least or something like that, but I'm just listing the points out. That way I know which ones I'm looking for in my answer choices. For my range, that's just going to be my y values. So my range value is 9, 16, 25, -36. And that's it. Done. Questions 10 and 11 are a bit more complicated. I'm going to try and zoom in here a little bit to give you so you can see it a little bit better. Question number 10 reads, what's the slope of a line 3x minus 4y minus 12 equals 0? Well, the downside with this, I wonder if I can extend this out a little bit. There we go, so it's not leaning. The problem with this is in order for me to identify slope, I need this in y equals mx plus b form, in slope-intercept form. This is not slope-intercept. I need y equals. I need everything else on the other side, and I need y all by itself. So I'm going to try and isolate y. And I'm going to show you a method here that I hope will help you. So the first thing we're going to do is I'm going to write the problem over here. I'm going to write it as 3x minus 4y minus 12 equals 0. The first thing I'm going to do to solve this problem is, again, I need to get y all by itself. So I'm going to add 12. So I have 3x minus 4y equals 12. Now, here's the part that trips up a bunch of students. We don't know what to do at this point because we have two variables. We have the x and the y, and we need to get y by itself. And so this often throws us off. So here's what I'm going to do. I'm going to write the problem like this. 3 minus 4y equals 12. You notice that I dropped the x value because I just want to know the method and the steps to get y by itself. That's my goal. So my first step would be to subtract 3. Now here's the difference in this. I'm not going to do this arithmetic over here. I'll do it over here because I need to get y by itself, but I'm going to hang on to it here. Let me show you. 3 minus 3 goes away. I'm left with negative 4y equals 12 minus 3. I'm not going to do 12 minus 3 and write 9. I'm just going to leave it. And my next step is to divide by negative 4. So I'm going to divide each piece by negative 4. 4 divided by 4 is 1, so I'm left with y. 12 divided by 4 is negative 3. Negative 3 divided by negative 4 is 0.75, but I don't want to deal with the decimal, so I'm going to leave it as a fraction. But it's a negative divided by a negative, so that turns into a positive 3/4. And now I have y all by itself. Again, that was my goal, to get y all by itself. However, I got to go back to this original problem over here and realize the change I made. This was 3x minus 4y equals 12. I changed it to just 3. So everywhere where this 3 would be, I'm going to put an x behind it. So here, here, here. And on this side, it would be here and over here on this one. Now I have y equals 3/4 x minus 3. Now that's in slope-intercept form. Now my slope is 3/4. And my y-intercept, even though the question doesn't ask for it, I'm going to go ahead and give it. My y-intercept is negative 3. Let's practice problem 11 together. Problem 11 is the same thing. What's the slope of a line 4x minus 6y minus 24 equals 0? Again, my first step is I'm going to go ahead and add 24. Add 24. Again, my goal is to get y all by itself. I'm left with, I'm going to draw it in blue for this next line. 4x minus 6y equals 24. This time, I'm going to leave the x there, but the method is still going to be the same. I'm going to subtract 4x. I'm going to be left with negative 6y equals 24 minus 4x, because I cannot combine those terms. Again, I'm not doing any arithmetic. Then I'm going to divide by negative 6 on each one of these. That's distribution, is what's going on right there. That's distributing right there. So I'm left with y equals 24 divided by 6 is 4, but 24 divided by negative 6 is negative 4. Negative 4 divided by negative 6 is positive, and 4 over 6 can reduce down to 2/3, and that's going to be x. So that's my equation, 2/3 x minus 4. So therefore, my slope is 2/3, and my y-intercept is negative 4. Oops, sorry. Kind of cut it off there. And if you notice something, I kind of want to highlight something about both of these problems. If you notice, your slope in this case is 3/4. And if you notice, your x value has a 3, your y value has a 4. And if you notice over here, your slope is 2/3. Your x value was 4, your y value was 6, which reduces down to 2/3. That's not a coincidence. That's very normal. And if you also notice, one of these was positive, one of these was negative. This ended up being positive. Same thing here. This one's positive, this one's negative. My answer ended up being positive. So you can use this to your advantage to quickly identify slope. It should be your x value over your y value. Similarly with b, 12 divided by 4 is 3, and 24 divided by 6 is 4. And if you notice, both of these are negative, and this ended up negative. Both of these are negative, and this also ended up negative, so that similar rule applies. If one of them is positive, one of them is negative, the answers will be positive. If both are negative or both are going to be positive, then your answer is going to be positive. Question 12 and 13 are pretty straightforward. Question 12 says, draw an example of a continuous graph. A continuous graph means that there's a connection point between them. So I'm going to go ahead and pick that point. I'm going to go ahead and pick that point, and I'm going to go ahead and draw a line. I do not need to make this complicated. Problem 13 says, draw an example of a discrete graph. Well, discrete graphs have breaks in them. So I can go ahead and do something like this and do some points. That's a discrete graph. Okay, it doesn't even have to be a function, so those could have actually lined up. You could also do something like this. Let's do this, and then this, and then this. And let's go ahead and connect some of them. There you go. That's discrete as well. It's discrete because all of those points are open. And there you go. There are the notes for the second page of your review.